In this video, we will be going over how to calculate the average atomic mass once again of a element. However, this time I will be extracting the data from a graph instead of from a chart. So let's go ahead and get started. Using the graph, calculate the average atomic mass of sulfur. So this is a graph here on the upper right hand side, sorry. And so right off the bat, I noticed that on the x-axis we have our masses, and on our y-axis is titled abundance, right? Percent abundance. Now, the title of this graph is relative abundance of sulfur isotopes. Hence, each of these little bars is really representative of an isotope, right? And each of these masses down here are the four different masses of the four different naturally occurring isotopes of sulfur. So it's just as if we were provided the data in a chart almost, right? So we are given the masses of isotopes, mass of isotopes. In this case, the masses are 31.972, 32.971, 33.968, and 35.967. These are the four masses that are right here. Now, it's kind of difficult to see the percent abundances of these four naturally occurring isotopes, so I'm just going to write them out so that you guys can better see them. I'm not sure if you guys can see them. Some of them are in between the lines and they're difficult to see, but these are the percent abundances. And these are in order these are in order as well, so they correspond, the order that I am going to put these percent abundances in correspond with the order of these isotopic masses as well. So the percent abundances are 94.93, 0.76, 4.29, and 0.02. Now, given that these are our masses and percent abundances for our four different naturally occurring isotopes of sulfur, we are able to now calculate our weighted average, right? We're able to calculate a weighted average. And so the setup for our weighted average calculation should look something like this. It should look something like this. Remember, when you are setting up your weighted average calculation, you want to make sure that you do not, that you either divide each percent abundance by 100 in the beginning, or if you do not divide each percent abundance, if you do not divide each percent abundance by 100 in the beginning, that you do so in the end. Otherwise, you will have an off answer, and so that's just how it is. Make sure that you guys remember that. It's crucial to obtaining a correct answer, and it's a very common mistake that prevents students from getting these problems correct often. I inserted all the percent abundances here as percentages. I did not divide them by 100, so I did not insert them in decimal form. So I'm going to be forced to divide the answer in I am going to be forced to divide the answer by 100 in the end. Sorry about that. Now, after we find the product of each of these sets and calculate the sum of each of these, of all of these products, we get an answer that's actually 3,206.598. Now, as I just said, I did not divide by 100, so I'm forced to do so in the end. And so when I divide by 100, my final answer is actually going to be 32.06 grams. So this is our final answer and our average atomic mass for sulfur. Now, you can notice here our most abundant isotope was this one here. It was isotope with a mass of 31.972 grams. It had a percent abundance of 94.93%. And so since it was the most abundant, we should expect our average atomic mass to be close to this. And indeed, our average atomic mass was close to this value, right? These values here are very close to each other. And so this is just sort of a way to check your answer and to see if you're on track. I hope you understood this video, and I hope you understood how to work out this problem after this video. Thank you very much. Have a great day.